All right, well, before we jump into a full proof of Dijkstra's algorithm, let's look at the assumption that Dijkstra's algorithm does not work with negative edges. So let's take this simple graph here as an example. What is the shortest path from S to T? And really, I guess I mean by that, what is the shortest path and what is the length of that path? Well, the shortest path would be to go across the top here, and that would have a total path length of 4. So it would be S to V to T. Now, what would Dijkstra's find? What's the shortest path Dijkstra's would find to T? Well, Dijkstra is going to find, in the first iteration, it's going to look at these two edges. If I'm going from S over here as my start vertex, it's going to look at the two paths, so a path length of 1 to get to V and a path length of -2 to get to T. So it's going to compute a path length to get to T directly from S, and the length would be -2, and it's never going to go back and recheck that. That's just sort of a property of Dijkstra's. It's called a greedy algorithm, which is something we'll talk about again later in the semester. So how might you deal with negative algorithms? How might you make this graph something that Dijkstra's could work on? Well, it's tempting to say that we could add some value to every edge. So for example, take the most negative number and just add that to each edge. So we could add 5 to every edge. So +5, +5, +5 is equal to 6, is equal to 0, is equal to 3. And our graph would then end up looking like this. Well, let's just check to see if this worked. We know beforehand the shortest path was to go through V to get to T. But now if we go across the bottom, that's a total path length of 3, and if we go across the top, it's a total path length of 6. So it turns out you can't just add arbitrary values to every vertex in the graph. There are some techniques that we'll talk about later in the semester where you alter the weights to get rid of negative values, but that just straight adding a single value to every edge does not work for Dijkstra's algorithm. So why does this not work? Well, if you notice, across the bottom, we've added a total of 5 to this path. And Dijkstra's cares about paths, not just individual edges. Whereas across the top, we've added a total of 10. So we've disproportionately impacted one path versus another path. So Dijkstra just doesn't work because essentially what we've done is we've changed the underlying meaning of the graph. It no longer represents the same data that it did. Okay, well, in the next video, what we're going to do is prove that Dijkstra's works on graphs that do not have negative edges.